Hello everyone, welcome to this channel, and for today's topic we are discussing system analysis and design modeling methods. Now these techniques are crucial for understanding and constructing effective information systems. So without much ado, let's explore what they are, why they're important, and some key concepts involved. So first of all, what is system analysis and design? System analysis and design can be defined as the process of developing and maintaining information systems. It involves understanding business needs, designing solutions, and implementing those solutions. And these methods serve as blueprints for system development, facilitating clear communication and ensuring that the final system aligns with organizational goals. Now let's discuss some key elements. Some of these elements include requirements gathering, process modeling, data modeling, user interface design, system architecture, implementation and deployment, and then overall maintenance. Now, there are several modeling methods, but for the purposes of today's discussion, we will just discuss the few prominent ones. Okay, so now the key modeling languages in system analysis and design include the Unified Modeling Language. That is one of it. Now, one may ask, what is Unified Modeling Language? It is a standard visual modeling language primarily used in object-oriented software engineering. Now, this was developed in the 1990s and maintained by the Object Management Group. The UML provides a comprehensive set of design types to visualize, and then it's also used to specify, construct, and document software designs. The UML also serves as a common visual language across the software industry, offering multiple diagram types that capture different perspectives of a system. Its scalable nature allows it to be used in representing both high-level abstractions and detailed implementations while remaining language independent so that it can be used with any programming language or methodology. Okay, now the UML also encompasses two main categories of diagrams: the structured diagrams and behavior diagrams. Structured diagrams include class diagrams showing system classes, attributes, operations, relationships, component diagrams that depict how components are wired together. Okay, and then the behavior diagrams also include the use case diagrams showing interactions between users and system. The activity diagrams represent workflows and business processes, and then the state machine diagrams display object states during the life cycle. The next one we're going to talk about is the business process modeling notation. In short, or the short acronym for that is the BPMN. Now, the BPMN is a graphical representation specifically designed for documenting business processes. It is also maintained by the Object Management Group, and the BPMN bridges the gap between business process design and implementation. Okay, the BPMN is a business-focused, designed to be understandable by all business stakeholders, with a process-oriented approach primarily focused on workflow and business processes. It features precise execution, and that can be directly mapped to process execution language, and provides a rich notation with a comprehensive set of symbols for complex business scenarios. Okay, now the main elements of the BPMN include flow objects, connecting objects, swim lanes, and artifacts. Flow objects consist of events, like something that happens during a process, such as a start or immediate or end event. Okay, then the connecting objects include sequence flows showing order of activities, message flows representing communication between participants, and associations that links information with flow objects. Okay, now the artifacts also include data objects showing information used or produced, and then the groups for visual organization of elements and annotations providing additional text information. Then the third one I also want us to discuss is the entity relational diagram. The short form of that is the ERDs. Okay, so entity relational diagrams are also a visual representation used primarily for data modeling, and they also used to show the relationships between data entities in a database or information system. The ERDs are data-centric, focusing on data structure rather than behavior, and a database-oriented, often used for database design and implementation. They can also represent different levels of data abstraction, from conceptual to physical, and are a standard approach for database modeling across industries. Now, the main elements of ERDs include entities, attributes, relationships, cardinality notations, etc., etc. Entities represented as rectangles correspond to objects or concepts about which data is stored, such as customer, order, or product. Attributes are also properties or characteristics of entities, often listed inside entity rectangles or connected to them. An example being a customer ID, name, or address. Relationships are connections between entities that are shown as lines, okay, described with verbs such as places or containers. The ERDs essentially exist at different levels of an abstraction. Okay, conceptual ERDs provide a high-level view showing major entities and relationships. Okay, the logical ERDs offer a detailed view, including all entities, relationship, and attributes. And the physical ERDs present an implementation-specific model, including primary or foreign keys and table specifications. Okay, so each of these modeling languages serves specific purposes in system analysis and design, with the UML focusing on object-oriented software structures and behaviors, the BPM emphasizing business processes and workflows, and the ERDs concentrating on data structures and relationships. So in summary, system analysis and design involves understanding business needs, designing solutions, and implementing those solutions. Now, modeling methods such as the DFDs, the ERDs, the UML, flowcharts, and wireframes are used to represent different aspects of the system, addressing concerns like changing requirements, communication, complexity, security, scalability, and user adoption, all of which are crucial for a successful system development. Thank you so much, and it's been a wonderful semester. I hope to see you again in another class. Bye.